Today, we will discuss how to conduct a systematic literature review, or SLR, using Web of Science. So whether you're preparing a PhD thesis, writing a journal article, or exploring a new research topic, conducting a literature review is very important. That's an essential skill. And by the end of this session, you'll be able to have a better understanding of the complete workflow. And it typically starts with a research question to synthesizing the findings and reporting results according to different standards, international standards. I want to start with the agenda. So I'll start with the first point I want to cover. We'll be able after the session to understand what makes a review systematic. We'll speak about how we can develop a clear and focused review question. Very important is the search strategies, how you can develop a search strategy that is reproducible, that other can reproduce on their site. We'll use the Web of Science for that. Next step is, once you've searched, I'll give you some tips on how to search effectively in the Web of Science, how we can screen and analyze the research data or the relevant studies. You have the last point, which is about reporting your findings, and I'll focus on PRISMA, the PRISMA framework. And today's session is more like a roadmap for producing a systematic literature review or review article that is publishable. What I want to do is first, what is a systematic literature review? From what I see on the ground, when I speak with researchers, many researchers believe or think that a literature review simply means reading papers and then you just summarize them. A systematic literature review goes much further. It goes beyond that. So it follows methodology to identify, evaluate, and synthesize all relevant evidence related to a specific question. Right, so that's the definition of a systematic literature review. And the keywords here are transparency, but also reproducibility. You need to explain how you've done your literature review. So it has to be comprehensive, reproducible, transparent, evidence-based, and if someone else or another researcher follows your methodology, they should obtain similar results. That's why systematic reviews, they are often considered among one of the highest levels of scientific evidence. And next is, why shall we conduct an SLR? That has different purposes. It takes a lot of time, it takes a lot of effort, but first of all, one of the purposes is, when it comes to research, is to help us understand what is already known in a field. So instead of starting from scratch, you want to understand what has been done, right? So you don't redo what has been done already. And second, it also helps us identify research gaps and opportunities for future work. You'll access different theories when it comes to your field. And we know that from a scientific perspective, on average, review papers often receive more citation than other research papers, like standard research articles, because they become reference documents for other scholars. I'm not going into too much details here. It's just the average, classic average number of citation for a review article is usually higher Obviously you won't use that as an indicator of performance. You would need to compare, as we say, apples and apples. So you would need to compare review articles with review articles. And of course, for young researchers, doctoral students, for instance, an SLR or systematic literature review can provide the foundation for an entire thesis project. And that's also the reason why very often PhD projects starts with a systematic literature review. So these are the research benefits, but then in terms of publication, of course, as I mentioned, high citation potential compared to other document types, strong basis for PhD thesis, and if done properly, of course, it's frequently accepted by high impact journals. All right, so let's now talk about the process. How do we do an SLR? I want to break down the process here. It has 8 steps, and this slide presents the overall workflow. So systematic reviews, they are connected through a series of structured steps. So we start by defining a research question, and that's very important. You cannot do an SLR if you don't have a strong or a proper research question. Next, we develop a protocol and search strategy. Then we search databases where you build your search query. You screen the studies. So we'll search in the Web of Science. You extract you screen the studies, extract the information, analyze the findings, and finally report the results. And that becomes your SLR, or systematic literature review. What I see, again, from my experience, is that many researchers, they jump directly to the database, right? And that's one common mistake. You jump directly into searching databases before, as I mentioned, very critical step is to define your research question so that the research question is strong enough. So everything starts with a well-defined research question. So let's start with each step. Step 1, how do you define a research question? There are a few, as I mentioned, each step of the process is structured. For the research question, we know that a systematic review is only as good as its research question. So weak question leads to weak results. A good question should be clear, specific, focused, relevant, researchable. And I'll give you an example here. I understand most of you are from the medical field. We could ask a question like that. What are the applications of generative AI in the medical field? So you'll see some of these questions across different fields, like generative AI is there in lots of fields. And there are several frameworks you need to be comfortable with that can help you formulate research questions. For instance, you might have heard about PICO, so that's very common in health sciences. So you take a population, you're interested in intervention, you want to compare, and then get the outcomes. In other fields like social sciences, you have something called SPIDER. So you take a sample, phenomenon of interest, design your study, you evaluate, and then look at the different research types. So in your case, you could use the PICO framework, the population you are interested in, the intervention of and the study, comparison, and then the results or the outcome of those interventions. The point of these frameworks, so you have different variants or variant frameworks across different fields. The goal is to establish strong boundaries for your review. I want to mention another one you might see also, a variant of the first one, which is called Peacock: population, intervention, comparison, outcome, and context. So you could use that framework and say, what am I using exactly in terms of population? What am I studying? The type of intervention and so on. Next step is to develop a review protocol. So before searching in the Web of Science, we need to develop a review protocol. So what do we need to include? Think of the protocol as a research blueprint. If you give this to someone else, they would be able to replicate or reproduce your search. So it specifies what we are searching for, the objective of your search. So that's also related to the research question. The databases that you use or that you're going to use, it might be one or several databases. Today, we'll use the Web of Science. You can access through the library at university. And then we'll start talking about the search strategy. Which studies we will include. So are you focusing on articles, review articles, conference proceedings, books, book chapters, and so on? You need to specify that. And which studies we will exclude. For instance, retracted publications or retractions or publications with expression of concern, right? And then you'll get some data, and what's your extraction plan? What's the data extraction plan? Why are we doing that? Creating a protocol before collecting the data, it's reducing bias and it proves transparency. And also it helps in terms of reproducibility. And you'll see that many journals now encourage or require protocols, right? So when you submit your literature review, you also need to submit the review protocol so that it helps in terms of transparency. So back to my previous research question, in this third step, I worked a little bit on identifying keywords. So my example here, generative AI in the medical field or in higher education, the concept mapping. I looked at the concept is generative AI, medical field, medical application. This is where LLMs or large language models can help. They can be very helpful in providing synonyms or important keywords. And that's very important because you need to think of synonyms before searching, right? So there's you do that step by step. You also need to test. I'm not from the medical field, but for the medical field, I'm interested in generative AI medical field. So I included those keywords, and also in terms of application. So it could be application, implementation, utilization, impact, diagnosis or diagnostics, pathology, and so on, right? Step 4 is you build your search strings. So here, that's a screenshot from the Web of Science. I went to Documents, Fielded Search, and I put my keywords here. And I can use Boolean operators, and, or, not, near, or near /x, near 3, near 5. So I want those keywords, but I don't want them to be too far away from each other. And some useful symbols as well. Double quote for phrase searching, and you'll get a query like that. For instance, where here I'm looking at those keywords that are related to generative AI, and at the same time, the papers that contain those keywords, right? Or the words that start with medical, medicine, and so on, right? So that's a query that is generated. And I use those truncation symbols, such as the asterisk, right? Which are quite helpful. Once you do that, you search in the Web of Science. In this case, I get 23,000 documents. I do a topic search. You can do a title search, author keywords. You apply the filters on publication years, document type, language, research area. So these are the filters you can apply, and this becomes the step that is necessary for step 5, right? So here you say, I'm interested in the publications from 2016 to 2026. I'm interested in papers with authors from a specific country. I'm interested in articles and reviews and conference proceedings and books. I'm not interested in retractions, for example. I'm interested in medical field, but within the medical field, we have lots of research areas or research fields. So I'm interested in internal medicine, for example, or pediatry or ophthalmology, and so on, right? So that's very important because that becomes your search strategy, but also your protocol. So you'll get your search results. Very important. Every search string that you run, and that's quite easy to do that in the Web of Science, you save it, because you will be able to include the search query in your paper saying, well, I use the Web of Science. Here is the search query that I ran as of June 2026. At that time, I got 23,000 papers, right? So this is something you can include in your paper. Right, so that's a screenshot. As you can see, you can play with different filters and build your search query. In this case, I'm searching on keywords related to the topic, meaning the keywords that appear in title. Right, so that's the example I run here. So I took my search query. I got 23,000 papers. And on the left-hand side, I have my filters. So in this step, I'm just running my search query. We enter the search string into the Web of Science, and we examine the results. So at this stage, we're just looking for the number of records retrieved. You can do some analysis here, analyze results. On the left-hand side, if I scroll down, and I will show you later on in the live demo, you will see the leading journals, the highly cited papers here, the emerging research trends, and something interesting, if you apply a filter here, you will see how small changes in the search query can affect the number of results. So that's my search query. I can analyze the results. I can create an alert, so I can save this. If there are any new papers matching my search query, I will get an alert. And of course, here I will have access to my filters. Next step is to screen the studies. Right now, at this stage, we are not reading the full text yet. We examine titles, we review the abstract. Then, if it's very interesting, then we can get into the full text. At this stage, I can check this publication and say I want to save it. I can save it to EndNote or any other tool like RefWorks, reference management tool, Zotero, Mendeley, and so on, so that you save what you're finding interesting. At each stage, you ask yourself, does this study address my research question? In this case, it's about medical imaging. So might be interesting in terms of radiology. From a radiology perspective, we know that AI is quite good at generating content, but also detecting patterns. So maybe it can help using different data sources to detect cancers, for example, very early, better than human radiologists, for instance, right? So the purpose here of this stage where we assess or we screen papers is to eliminate the records that are irrelevant. And we maintain transparency. So you would say, well, that paper was not interesting. So screening levels, level 1 is you look at the title screening, level 2, the abstract, level 3, full text, And you ask each time, does this paper answer my research question? If yes, you keep it. If not, you move on. And that's where you start looking at some patterns and you say, well, maybe in my search query, I should have included more filters, more criteria to include or to exclude irrelevant papers, include those that I might have missed, and so on. So for example, we might include only peer-reviewed articles, no dissertation, no thesis. You can focus on English language studies, for example, or you want to focus on papers that come out from Oman or from the Gulf countries, for example, or from the Western Asia, for example. And you could say, well, I want to focus on publications from 2020 to 2026. In terms of document types, you may exclude editorials, book reviews, conference summaries. And the important point here is that these criteria should be defined before reviewing papers, not after. So you say, I focus on primary research. So articles, review articles, books, book chapters, conference proceedings. You could include preprints if you're interested in preprints as well. And that's typically what I use when I'm interested in the literature. Right. Exclusion criteria, as I mentioned, no editorials, no book reviews, for instance, no retracted publication, and no relevant studies. Then we started talking about PRISMA. PRISMA, very famous framework. So PRISMA stands for Preferred Reporting Items for Systematic Reviews and Meta-Analysis. So that's an interesting screenshot from the original study. That's the PRISMA 2020 statement, got updated recently. So that's an updated guideline for reporting systematic reviews. I'm not going through all the steps, but in a nutshell here, it's a framework which is preferred for systematic reviews, and it is the most widely used reporting framework for systematic reviews. In short, PRISMA helps researchers document how many records were found. For example, in our case, it was 23,000. How many were removed? Why studies were excluded? How many studies were finally included? And so on, right? So you explain here, you say, we got, that's one database, we used Web of Science, we got X numbers of papers, we looked at the eligibility, we excluded those because for reason 1, 2, and 3. And at the end, you get your final number of results. So that improves the transparency of your work, and it also helps readers to understand exactly how the final data set was obtained when you were doing your study. So PRISMA, very important, preferred reporting items for systematic reviews and meta-analysis. You have those 4 main stages: the identification, the screening, eligibility, and inclusion. Once you have your final data set, then it's time to go deeper on the literature. So you want to extract the data. You can do that in the Web of Science. You can export the publications in the form of a text file or an Excel file, and you can get something like this. And you say, for instance, I found this paper by Ahmed Abdullah from Oman in 2019. The method used, so I read the paper and I say, in that study, it is a survey. Their sample is based on 450 patients and positive impact on the use of AI in the medical field, right? So these data, the metadata, you don't start from scratch. You can get that data directly from the Web of Science, and then you would fill your Excel file with your own analysis, right? So let's say you end up with 250 papers, you get an Excel file with 250 rows. For each row, you give the typical variables, so the author, the year, the country, in this case, the methodology, sample size, and the key findings. And that extraction, right, so where you extract that metadata is, you don't need to extract it yourself. Web of Science can help you do that. You just export the metadata into a text file. But that extraction process, it converts a collection of articles, let's say 250 papers, into something that is structured. It is a structured Excel file, structured data set that can be analyzed systematically. And you need to be consistent here. That's very critical because that's the basis of your study. So as I said, you can start by extracting or exporting the metadata from the Web of Science to Excel and get publication key takeaways from the Web of Science Research Assistant. I will show you how to do that with the Web of Science Research Assistant. So this step is about creating an extraction table. Right. So next, you want to analyze. After data extraction comes synthesis. In this case, I just took an example of a bibliometric analysis. That's one type of analysis we can do. There are different approaches. Narrative synthesis, where you summarize the findings. Thematic analysis, you identify recurring themes. And in this example, it's about bibliometric analysis. You want to measure influence and trends, right? So, and you see that's a poster in the conference. Methodology is, you get, again, using PRISMA protocol. Citable publications, what does that mean? It means articles and reviews from 2010 to 2019. Indexed in the Web of Science, we look at conference proceedings as well. We look at this classification, and we look at papers that are related to the topic of interest. And they found 1,962 papers. And then the results, different analysis that you can do with the Web of Science, with insights, where you can get a good sense of this analysis. So that's an interesting study where you can you have access to the poster here, following the PRISMA protocol, and you see very quickly in one single page we know what this study is about. I'll show you another one, right? Bibliometric analysis of global health literature. We look at the background, what they're interested in, the methods, 3 user groups, faculty. They look at one specific institution from 2010 to 2013, right? And they also look at different analysis. Publication type, it's mainly journal articles, age of citations, top subjects, the observations, and the top journals. Again, that's a classic bibliometric analysis. So there are lots of analysis you can conduct: more cited papers, more productive authors, leading institutions, country collaboration, keyword co-occurrence, and you can use different tools like the Web of Science, Insights, Voice Viewer, Bibliometrics, SciSpace, and so on. And these analyses, they can strengthen the contribution of your review. It's not only about what's there in the literature, but also the landscape analysis of your topic of interest. Now I want to speak about the research assistant. So there's an interesting tool that is quite powerful, where I just simply ask the question, what are the applications of generative AI in the medical field? And then I follow the steps. So this is what is called agentic AI. So it goes step by step. And in this case, I was interested in doing a detailed literature review, because I know that in the literature review, it will also provide a search strategy and also the research gaps. For example, population that are not studied enough, limited geographic coverage, weak methodologies, some findings that are contradictory, and so on. Right. So how do you do that? I'm interested in those topics where there is clearly a gap. Topics not studied, geographic gaps, and methodological limitations. And again, contradictory findings. So I asked the question, and the assistant is telling me, well, this is quite broad and an important topic, and it has several possible directions. Diagnostic imaging, That's the example I took earlier, the radiology. Or, for example, you're interested in, you use generative AI to synthesize medical data, right? You have lots of data. How do you use LLMs to synthesize medical data? And that's what I took. I said, well, that's what I'm interested in. It understood that even if I made a mistake here, spelling, you see, medical data synthesis, I made a typo. It still understood what I'm interested in. And I put the link here. So in the presentation, you simply click on the link and you'll see the full conversation I had with the assistant. And that's quite interesting because you see, initially I had a broad research question and the assistant said, well, it's quite broad. It has to be more precise. So this would be the objective of my initial research question. Okay, medical field, too broad. I'm interested in medical data synthesis, which is more precise. And it goes, and it generated a query, right? And it gives me the common themes, but also the research gaps. And that's also the goal of systematic literature review, right? I wouldn't stop here. I would take this query and follow the previous steps that I explained earlier. So this is a good starting point. It's giving me the common themes. And now it's also giving me the gaps in research. So before showing you how to do that in the Web of Science, I want to highlight common mistakes to avoid. First of all, research question too broad. The example I gave was an interesting one. Use of generative AI in medical field, interesting, but very broad. And we started with 23,000 papers. We should have put a filter on the poor keyword selection if you're not precise enough in the synonyms. The inclusion criteria, what type of documents are you including or excluding? There is no screening protocol. So are you looking at titles, abstract, before jumping into the full text? Which period are you looking at? Reporting. Even if this is strong, you need to report properly. And weak synthesis. You might get very good data, but your review, and that's when you write your manuscript, is weak, and that's a common mistake to avoid. So key takeaways: start with a clear question, use a reproducible search strategy, apply transparent screening, follow PRISMA guidelines, you synthesize your findings systematically. And what I want to mention here, once you're happy with your search query, don't forget to save your search query so that you keep track of what's being published. So what I want to do now, I want to show you how you can use that in go through these different steps in the Web of Science. Okay, so I'll just go to the Web of Science. That's the landing page. As Huda mentioned, you can access the Web of Science through the library portal. And you have the advanced search. That's what I initially used, but also the research assistant. So here I'm using the Web of Science core collection fielded search. Landing page, you will see again, this is my search query. All right. So two components. The first bracket where I give these keywords and I combine that with and here, and I can go back to the search query. And within a few days, it was last week when I've done the search query, it was 23,700 plus. Now it's almost 24,000. And here, you could go through the different steps. You say, well, analyze results. I can save this search query if I'm happy with that, but I can go beyond that and say, right, well, now I didn't put any filter on the time period. I can go back to the search query here and say, I'm interested in papers from 2016 to 2026. Okay. slightly more than 10 years. And it's very interesting. You see, it looks like we excluded previous 2016, and we only removed 1,000. So it's quite a hot topic. It's a very recent topic. Right, you could also do that. You can visualize that. If you look here, publication year, you get a trend, and clearly since 2020, 2023, where we get the majority of papers about use of generative AI. Before that was quite low output. So here, another filter I can use, and that's what I personally do. I focus on articles, conference proceedings, reviews themselves. Early access is fine. Letters, I'm not interested in letters, no editorials. And no retracted publication. I can include book chapters for methods. That's very interesting. Also book reviews. For the rest, I'm not very interested in that. Not interested in news and so on. Right, so that's also a good way. And you see from 23,000. And I start building my search query. This is my keywords, document types. I'll put a filter on, let's say, those years where we see the majority of publications, right? Generative AI being a field that evolves quite quickly, very often you get new models and so on. And now you see, I get my search query. This is something I can share with all of you, right? Let me put that in the chat so you can see. If you open that here, this is something you can access yourself. And for transparency purposes, once I'm happy with my search query, I would include that in my study. And I say, I run that study as of 29th of June, 2026. At that time, we had 20,000 papers. Of course, I wouldn't stop here because what you could use is those filters on the field, and you say, well, I'm interested in generative AI, so I'll keep AI, medical informatics. Maybe in your case, you're interested in the use of generative AI in surgery, right? For instance, or in oncology, right? So and again, that updates my search query, right? And I can be more precise. There are more filters I can use. For instance, when it comes to AI, there is the natural language processing. In this case, you would use, for example, a tool like a large language model to synthesize large data sets, text, right, medical data, and so on. So you can focus on specific topics here. Use AI to detect depression, or image analysis of the eye, or the retinal image analysis, and so on. Okay, so it's up to you here to decide, but you need to be precise and say, okay, I'm interested in natural language processing. And that's quite interesting because if I go back right here, that's also give you an idea of where generative AI is used in the medical field. So you see, for example, pancreatic cancer, speech recognition. That's quite interesting. Colonoscopy and so on, breast cancer imaging. So that's where you could also say, well, that's what I was interested in at that time. Okay, and by doing so, I keep building my search query here. I can be more specific and say, well, I'm interested in this, but I want to analyze, I want to review the literature from specific countries, right? So I would put, so that's a different goal. I want to have a good idea of the state of research from the GCC, right? For example, so I'll put Saudi Arabia, UAE, Kuwait, Qatar, and so on. So I can add, so these are the top 100. I could do that and say, well, I'm doing a literature review or systematic literature review to understand the development of or research on generative AI, and that's your objective, right? Could be something else, could be on the whole world. In this case, you would put a filter on the country. Once you have done that, you can export this as an Excel file or a tab delimited file. So let me show you. Okay, so I need the metadata. I'll keep full record is fine, from 1 to 900. And that's, of course, here I'm exporting. I'm going a bit quickly because time flies. But before exporting, I would screen here and say, well, I want to keep this one, not this one, and so on, right? And here, once you selected those studies, you can export to Excel. So let me show you. And that's your starting point for your data extraction. You don't have to start from scratch, because in here, so here C is for conference proceeding, J is for journal, the author line. I can keep the full name. So you start building your data extraction from an Excel file. So this data is already there, right? You don't have to extract it yourself. So these are the full names, okay? Article title is good. We'll keep it. The source, language is fine. Document type, okay, this is something we can report on. So if I keep the document type here, there is no need to keep this abbreviation. All right. Conference details is fine. We can keep that. The author keywords, very important. We'll keep those. Okay. And the abstract, very important. The affiliation, we can keep the affiliation. The email address, why not, if we want to reach out to get more insights of the researchers, the email address of the researchers. The IDs is not necessary. Funding is an important information. When you see here that the funding data is also interesting, especially in the medical field. The citation data is, why not, if you want to do some analysis on that. Publication year, I will keep it, right? Volume number, not necessary. The DOI, or the link to access the study, very important. The Web of Science categories, right? So we retrieve those fields that we've seen earlier. These are the categories of the journals. And yeah, and something you need to keep is the data of export. So this is as of today. The ID in the Web of Science, and so on, right? And from here, I would add the different columns saying the main findings or the key takeaways of each study. And something you could do is the following, for instance. Of course, you need to do that yourself, but you could ask the research assistant. So if I go back to the Web of Science, so this is the link to the PDF. I just clicked on it. But here I could say, okay, I want to go back to that study, and I will go like one by one. So I put the ID. That's the DOI, right? I need to retrieve only one record. Title, abstract. And I can also use the research assistant here. That's what I've done. What are the application of generative AI previously? And I follow the steps. It generated that query. It found 91 papers. And of course, I can go one by one and say view all records in the Web of Science. And I could say summarize this one, for instance, which was the paper I was looking at earlier. That's the research assistant. So that's in a nutshell how you can use the Web of Science to do some analysis. Okay, so because it was not in the search results, so I will need to create a new chat. Right, it's in summarize. That paper was not picked in the previous query. Let me have a look at the chat because I could see some messages coming up. Yeah, I'll fix the slides at the beginning of the recording. For some reason, I was not sharing at that time. Yeah, it's okay, Huda. I can see you unmuted yourself, but I couldn't hear you. That's all right. Thanks for the link to the website and the different steps. Yes, I will share the slides. Question from Malak. Another question. So in the protocol to be written was specify research objectives, inclusion and exclusion is like a framework. Yeah, it is the PRISMA framework, but that's a very important step. You need to mention what you've done to include or exclude. Yes, I will share the recording. So we already replied. Yeah, all of that, all the information, the slides recording will be shared by email. Yeah, so good question from Abdullah, who says, to what extent is it ethically acceptable in scientific research to rely on artificial intelligence for summarizing studies and extracting key information? So there, with summarizing large corpus or large volumes of text, but they're not perfect. And that's why we call them assistants. And the way I see it is if you use AI, first of all, you need to disclose it. But before publishing anything that AI produces, you need to check, because at the end, you are responsible for what you put in your paper, right? The AI is not an author. You can use it as a tool, but you are responsible for checking the accuracy and of that content, right? So I consider that as an assistant, not a replacement. And I wouldn't rely, to answer your question is to rely on artificial intelligence. I wouldn't rely on 100% on AI. It's just a quick heads up, right? So you would still need to spend some time. And that's the reason I started with the traditional way of going step by step, paper by paper, to decide what you include, what you exclude. Yes, you still need to engage with the literature. You still need to access the full text, because you're responsible for what you're writing in your paper. Yeah, so I see that question is quite similar to to use AI for data analysis. It is possible, and that's also a good use case to use AI generated visualization instead of traditional tools like Excel, SAS, SPSS, Python, and so on. I recommend, because LLMs are quite good in, taking care of such visualizations, but of course you need to check what is produced. Yes, this seminar is recorded. I don't see any other. Okay, I saw. So these were questions. The direct question. Okay, share the slide. Yes, I will share the slides. Yeah, I'll fix that in the recording. You will see the different slides in the recording. I will edit the recording so the slides are there. Okay, I don't see any other questions coming up. We still have 3 minutes. If you have any other questions, feel free to ask them in the chat. Yes, the certificate is also shared by email as soon as possible. Yeah, good question. Is it required to mention in the end of the paper that AI has been used in the search process? So the general response is, or answer is yes. But I have to say it depends on what you used AI for. So it depends on your use cases. Some journals, for example, when it comes to language, editing, spelling, and so on, they don't consider, they don't require you to disclose the use of AI. So you need to check with each journal. Each journal or each publisher has its own AI policy. So you need to check with the journal. Yeah, so for the Web of Science, the research assistant, yes. So if you use it, you can include the link to the chat as I'm putting the slide and say, well, that's my search strategy. That's what I've used uh, to get a quick start, and that was the objective, the purpose of my analysis in the Web of Science. Yes, can I go back and modify my research question after analyzing the data? You could do that, and that's actually a good step. That framework is like a wheel, right? So as soon as you start engaging with the literature, you realize that perhaps your research question was not clear enough, it was not precise enough, right? And that goes back to the inclusion and exclusion criteria that you need to. All right, so I don't see any other questions coming in, and it's already time. Thank you very much for your participation. As I said, you'll get your certificate by email as soon as possible. I wish you all the best. Thank you very much. Take care.